Trees are a special case of graphs, and they have a very important place in information technology, so they deserve our attention. A tree is a connected, undirected graph with no simple circuits. In other words, in a tree there is only one path between every two vertices. So if you have not connected simple graphs, then you call them forests. And each of the connected components are trees. We have that an undirected graph is a tree if and only if there is a unique simple path between any two of its vertices. Now, if you designate a vertex as the root of the tree, and if every vertex is connected away from the root, then you have a rooted tree. These rooted trees are important. I can think of right now on protocols that use trees. And they use trees for routing packets in networks. So it's very important to understand the basics of trees. The tree terminology is very similar to what we're used to in regular terms of family relations. So you have the parent of a vertex is the parent that came before that vertex. So there is an edge from the parent to vertex V. The root has no parent, is the only vertex in a tree with no parent, in a tree with more than one vertex. And in the same way, a V is called the child of U, is the child of its parent. Then you have siblings. Siblings have a common parent. And then you have that the ancestors of V are is its parent and all other vertices in the path from the root to U. But the root is not considered to be an ancestor. So a vertex that has no children is a leaf. And vertices with children are called the internal vertices. So the root is an internal vertex unless it's the only vertex in the tree, in which case it's called a leaf. So the root, if it's the only vertex in the tree, is not an internal vertex, it's a leaf. The next definition we have is the M-array tree. So that means that the vertices in that tree have at most m children. And if all of the vertices have m children, then you have a case of a full M-array tree. In the case when m is equal to 2, then you have a binary tree. And you will see for network encoding, for data encoding, if you look at Huffman codes, you will see that you use trees. In particular, you make use of binary trees to find out the optimal coding of some string of characters. During the synchronous session, we'll do some exercises, and that will close our section on trees.